of saying, having a list, because before your calculator, they'd say you got log base 2 of 8. Yeah, that's obviously 3. And log base 2 of 16 is obviously 4. But they'd have a table of values all the way through from here to here. And they'd say, log base 2 of 9 is 3.17, because somebody had figured it out really precisely. Log base 2 of 10 is 3.28, making stuff up. And they'd have all the decimals in between. Oh, you'd need that, eh? Now, you'd have to do that for base 2, and base 3, and base 4, and base 6.7, and base 21.8, all the bases. And so instead of doing that, often we had a really detailed table of one base, log base 10, also log base E. There are some ways to find the fussy decimals in between those. And so instead of using log base 2 in your calculator, you'd use log base 10 and turn this into base 10. And then you could use the previous, all the table that they knew really exactly. And so I want to show you how that works. We don't really need to use it like that anymore, but we can use it to simplify problems. Yeah? So on your calculator, we can put in log base 2 if you go through the menu button. And I think you know how to do that by now. You'd go bing, bing, right? Math down to log base, right? And so you would say log base 2 of 9. Just how many 2's do I need to multiply to get to 9? 3 and a little bit, right? Okay, not a big deal. But you'll notice on your calculator, this is log base 10, and that's log base E. And so you kind of have to go through a special menu to get to the log base, whatever you want. And so we can turn anything we want, any base we want. We can change it over into a base that we have or know about, maybe base 10, maybe base E, maybe something else, with the change of base rule or formula. This is in your formula booklet. You don't need to memorize it. But I think that you can derive it yourself. I think it's an interesting little derivation. So I'll set you up and then see if you can mess with it. So let's just start with log base B of A and call that X. All right. So really B to the X is A. Start with that. B to the X is A. Let's try these couple of steps. Take log base, whatever you want of both sides. Let's call it base C. Start with that. Take log base C of this chunk, log base C of that chunk. It's like taking the square root of both sides, or dividing by 2 on both sides. It's the same operation, legal. See if you can pull out the exponent x, because we eventually want it to say x equals. Right? So pull out the x with the power law, and then see if you can get the x to sit by itself. Try that. Eventually, we want something that looks like this. Too bad. Divide off that log C of B. It's kind of nice. And then we just switch out x for what x was in the beginning, which is log B of A. Driving it manually. Right. So all this means is, previously, this is the way you would solve logs that weren't base 10 or E. You'd switch it into log base 10E. We don't need to do that anymore because the computing power is a little bit better, but we can still use this trick if we want to switch over a base to something that's more favorable or more useful. So we have base B of A. We can pick any other base we want, like base C. It's arranged neatly, right? Like I like how it's arranged, like B is still on the bottom and A is still on the top. And so that's just visually how I do it. There's no real reason for that aside from we're dividing.
But it always has to be on row.
So it's in that same, this one's higher, so it goes up there. Log C of B on the bottom. So you can take whatever base you have and divide it. So instead of saying log base 2 of 9, we put that in our calculator just a second ago. We found that was 3.16. You could instead call this log 2 of 9. We could call this log base 10 of 9 over log base 10 of 2. And so if you have like an old junky calculator, you can go log 9, bam, divided by log 2, bam, 3.16. And if you do it with natural log, same thing. It's a base E, log 9, bam, divided by log 2, bam, still 3.16, right? Any base you want. We just have base E and base 10 just stuck in there already. Yeah?
What's E?
E is a number like pi. It's 2.17. It's, remember when we were talking about exponential growth and the population of 1 billion bacteria, they don't weigh and double. Like some of them here have doubled a little bit, and some of those have doubled, and some of those have doubled. And so you get some extra. Instead of just 2 times, you get 2.7 times as many when you're talking about big populations.
Why do we use it in this?
Because they used it in this because this, when you're talking about logarithms and exponents, e to the x has a very easy derivative. And so I think it's easy to do some tougher calculus to find these nasty values using more challenging like mathematical techniques that we haven't gotten to yet. But it's easier to approximate these little tiny decimals with e to the x because it plays a nice game in calculus. It's behaved itself a little bit.
So you always put the bigger number on top.
You always put
Or the number that's
the base
goes on
on
bottom.
the bottom and the result goes on top. Cool. You try this one. Try that one. Throw that in your calculator. I'll run it with the non-change, the choose your own base. I'm doing the choose your own base. You do the divide the base.
Oh, no, I didn't use that.
I know, pink calculator, baby. Pull that thing out, wind it up a little bit. What do you have to do? Like, do you have to plug it in? Should we plug it in? You have to expose it to the sun. Get the hamster running on the little wheel. So I got 1.77, and if you use, let's use natural log. You'd say natural log of the 7 divided by natural log of the 3. Shazam! Still 1.77. Cool.
But how does natural log and normal log?
Natural log is base E, base 2.7,
Yeah.
and log is base 10.
Yeah, but then how makes it that they both equal 1.77?
Because that's the cool thing about change of base, is it doesn't matter what you choose for C. This is the same as base 10A, base 10B, or base 1 billion A and base 1 billion
Put
B.
anything into C.
Right, anything you want, which is nice because then you're in control of what the base is.
Okay.
We just like to use it on this calculator because they've already got base 10 sitting there and I can just hit off button.
Okay.
So that's like short-term goal is just like be able to hit a button. But long-term goal is also to be able to solve things exactly like this. Right, so they say solve this exactly. You've played this game before. See if you can kind of factor this. It'll give you 2 parentheses and solve one of them. When they say exactly, use like base 10 or base E and like leave it as a fraction. Try that out. You can factor that and solve it. Say no.
No. I like the action now.
No.
We can practice.
We're all so lonely today. Look at this sadness. Everyone's like,
Oh.
Can we make 4? Why? I don't get the point.
There's no point in mathematics aside from mental gymnastics.
No, I just don't get, like, if you can, let's say, put in log 3, 7, why are you going to do log 10, 7?
Right.
11?
We wouldn't. But what you can do is change the base. So changing the base isn't that helpful for calculation anymore because we can do that on our calculator better.
so what's the helpful thing?
What we use it now for is simplifying algebraic expressions, being in control of what the base is. Sometimes it's helpful for just maneuvering the mathematics.
I don't even know what you like.
I'll show you a couple. I'll show you a reason you might use that. So this is something that we've used before. I know this is 4x, and I'm looking for something similar in here, right?
What if you make 4 to the x n, and then you've got 2 of the n's?
Yeah, I like that idea. So I'm going to try to simplify this and put this in terms of that. I sense there's like a quadratic or something in here.
So annoying.
This thing, this is 8 is 2 cubed, and 4 is really 2 squared. I can't really turn the 8 into 4s, and I can't really turn the 4 into 8s, but I can turn both into 2s. What's nice about that, if we switch these around, this is really 2x cubed and 5 times 2x squared. And that's gnarly, but I have 3 of these, and I've got 2 of those, so let's pull 2 of them out of each one. So let's go 2x squared, pull those out. What's left over in her is one of these 2 to the x's and a minus 5. So you played this game before, right? If 2 things multiplied together equals 0, either this is 0 or that's 0. This one can't really be 0, right? Like 2, I've got 2's, I'm multiplying bunches of them positive together. When you get 0, you don't. So there's no solution attached to this one. But this one might have a solution. One is 2x minus 5 equals to 0. Kick the 5 over and then bash it with a log. So log base 2 of 5. Great. If you're there, I'm happy. You know logs. If you want to switch it to with the change of base, you could call it log 5 over log 2. I think that's what they're going for with this exactly. Now, they would do the same thing probably in a IB style question with just A's and B's. And they'd say, leave it in terms of log A over log B. And so you have to get here and be able to switch it over. Or they like natural logs. So probably they'd say, leave it in terms of natural log of A over natural log of B and tell me what A and B are. And so you'd get here and go, change of base, 5 and 2. Right.
So change base is not even that hard.
No, it's not. And you could derive it if you forget it, but it's in your formula booklet.
What level is this question?
That?
What is non-divisible?
No, that's a out of 8. Are we out of 8? Are we at 7?
Oh,
That's a 5. That's a 5 out of 7. 4.
nice.
4. It's nice.
Maybe a 3.
Maybe a 3. All right. One last one before we go. Trial by fire. See if you can solve for x with that. Leave it in nice and easy.
Sorry.
I don't know what to do. I have no idea.
Mary, do you want to enlighten us?
Yeah, okay. Basically.
So basically,
Well, you can have 2 log 4s, because it's 16 and a log 4.
can you do something that's... Can you just take out a log 4?
What do you not like about those?
Everything.
Well, I want to push them together. I want to smush them together. But what's What's not nice?
They don't have
16.
big-
They don't have the same base. What do we have a tool to do?
Change it.
Change it to whatever we like, right? You're in control. So pick a base. Pick base pi. Right? Whatever.
No.
No.
Wait, so you can do log. So natural log x over natural log 4, natural log x over natural 16,
Yeah.
and then multiply by 2 to get the same denominator.
Genius.
Cool.
How do you go from log natural log 4?
You want to? Should we go for natural logs?
Yeah.
So it looks
Yeah.
So
sweet.
you can write less letters.
I love it. I love it. We can say lon too. All the cool mathematicians say lon.
Well, we're
It's
saying
a natural log will be,
yeah, natural log.
Yeah.
log.
Yeah.
but you write that out.
So do you multiply 1 by 2 now, just so to get the same?
So, oh, we need. Oh.
Or
we
you
need-
multiply by log n, log natural log 4. Sorry. Or how do you do this?
That's good. I want I want to push these together. So I want the 4 to be a 16,
Yeah.
right? How do you get a 4 to be a 16? You square it, right? And so I bet what we could do, if we want to square this, wishful thinking, I want to do this,
Oh, but you can. No, you
right? So I don't know any rules about squaring the top and bottom, but like, where could that have come from if we're dealing with logs?
From the front.
Yeah, it could have come from here. So if I want to inject a 2 in front, just do it up there too. Boop.
Oh, yeah.
2 over 2, right? I'm not changing the fraction. And then weasel that 2 up into there. So this becomes 2 ln of natural log of 4 squared.
You forgot the n.
Thanks. Well,
This is fun.
Which is fun, yeah?
But you think you're funny.
what's nice about that is that's 16. We can crush them into just 1 log in the denominator. Natural log 16. I've got 3 log x's, natural log x's up top.
We don't do this. Please don't do this.
Kick the 16 out. Actually, even easier, divide both sides by 3. You get a 1 over here.
Oh, God. You got log.
So natural log of x equals 1 times natural log of 16. What's the x equal?
Oh!
Well, no, we're multiplying to get rid of this.
Wait, what is this?
Like we go multiply, cancel, multiply. Nice, right? Change the base.
But when you divide it by 3, why did anything happen to the natural log 16?
If you do this, if you go 3 over 5, and I divide by 3, it's 3 over 5 times 1/3. Those cancel. The 5 still in the denominator. If that freaks you out, move the 16 first. So
And
then,
then divide by 3.
yeah, visually, I think that works a little better.
Yeah.
Cool. Let's change a base.
That's so
Now,
cool. Ah.
now you know how to do logarithms. You and Keanu.
Sorry, that was
Cool.
Excuse
I'll
me.
bounce around, give you hands, and we can look at your spiral review if you like.
So